A black hole is coming straight for Earth. We could wait for it to gobble us up, but instead, we're going to try to destroy it. We'll throw everything we can at this black hole, from nukes to advanced technology that we might not even have access to yet. Maybe we'll even try to throw a white hole at it. You know what? Enough questions. We have a serious mission to accomplish. And if we don't, humanity will go extinct. This is Simplify Science, and here's what would happen. Nuke it. Okay, our first attempt at destroying this black hole will be to nuke it. We're going to collect every single nuke on Earth and launch them at this black hole that's speeding right toward us. This will produce energy equivalent to 425,000 times the atomic bombs of World War II. Now we know that the destructive blast of a nuke decimates anything. So all these nukes should do the trick, right? Well, not so fast. Black holes are tricky. Because what they do is consume. Like some kind of super-hungry space giant, they want to suck up all the matter and energy that they can get their grubby, little cosmic hands on. But let's try launching our nukes anyway. As they enter the black hole, you sit and wait for the massive explosion that will destroy this celestial phenomenon. But instead of being destroyed, the black hole eats the nukes for a snack. And now it's more massive than before. Oh great! What is a black hole? Well, as the saying goes, that what doesn't kill a black hole only makes it stronger. Or something like that. Bullets, lasers, and ginormous super weapons won't work either. So is humanity just expected to suffer the fate of being gobbled up by the black hole? No, you are not going to let the human race die out. But it's clear we have to try a more crafty strategy, one with artificial black holes, white holes, and maybe even a time machine. But before we get to that, let's figure out the basics. After all, as Sun Tzu said, know thy enemy. So what makes a black hole tick? Black holes are these superdense areas in space. So dense, and so gravitationally strong, that not even light can escape them. And it's estimated that our Milky Way galaxy has 100 million of them. Now, a black hole can form in two different ways. One way is when a cloud of gas collapses. These types of black holes can be enormous, 1,000 to 100,000 times the mass of the Sun. Then, there's a second way. Stellar mass black holes form when a massive star explodes and dies, leaving behind a very dense core, which is the black hole. These are smaller, with masses just a few times that of our Sun. Spaghettification. Now, what happens when we get a little bit closer? Well, as you approach the mouth of a black hole, you reach a boundary called the event horizon. And once you cross this event horizon, well, you're past the point of no return. Its pull is just too strong. Like I said, even light can't escape. And if you fell in, feet first, you'd actually be stretched and squeezed simultaneously by the extreme gravity and pressure. The official term of what would happen to you is called spaghettification. Sadly, it's got nothing to do with meatballs or a nice bolognese sauce. The scary thing, of course, is that black holes are constantly growing bigger and bigger and bigger by swallowing more and more matter. And now, it looks like Earth and all of humanity is on the menu. Oh, and one last thing about black holes. Like many other objects in our universe, they have angular momentum. In other words, they spin. And they have a charge associated with them. These are properties that need to sync up appropriately with the mass of the black hole in order to keep it in business. Just like if you were running a marathon, your body temperature and your blood pressure must stay in the right zone so that you can keep running. If you overheat, you might faint and fall over. Keep this in mind, as it might play an essential role in taking down our black hole. Creating an artificial black hole. Right, now that you've got a handle on what we're dealing with, well, it's time for a new attack. Oh, yeah. We know we can't defeat this sucker by simple tricks like nukes. No, we've got to come up with something better. So we're going to do something pretty crazy. Let's try making our own black hole and see if it can defeat the one coming after us. But how do we do this? Well, the first step is making our black hole out of antimatter. Antimatter is just like matter, but with all the opposite properties. It's like the arch-nemesis of a black hole. Antimatter. Of course, there's the small problem of actually making a whole lot of antimatter. But no worries, we have the technology to pull this off. All you have to do is accelerate a bunch of protons until they're nearly at the speed of light, and then you fire them into a material like iridium. This collision knocks out some of the fast-moving antiprotons. And the antiprotons are then slowed down and focused to help create antimatter. Oh, and we probably need this antiproton gizmo floating in space to create an antimatter black hole at the right coordinates. Definitely a little tricky to pull off. So what's going to happen when we crash our antimatter black hole into the regular black hole? Well, once these two forces crash, there'd be a mega explosion of pure energy. But unfortunately, it doesn't work as intended. The energy from our antimatter just gets vacuumed up by the regular black hole. And it's now even bigger. Ack! Okay, this is not looking good. And the black hole is getting closer and closer and bigger and bigger. And we're running out of time. We've got to try something else. White holes. Since the black hole is getting bigger from us feeding it, well, maybe we could just starve it. Simplify science, we figured out a way to stop it from eating anything else? Well, that wouldn't work either. Because the original mass of the black hole would still exist. But simplify science, you tried the opposite? Simplify science. Instead of starving the black hole, you fed it with something. Something that's constantly throwing stuff out? But what could that be? My mom. Maybe the answer is a white hole. White holes function in ways opposite to black holes. The two of them are like yin and yang. If nothing can get out of a black hole, nothing can get into a white hole. If we threw a white hole at a black hole, the two just might annihilate each other. But they wouldn't disappear. There'd be a big burst of energy and a ton of gamma radiation. You'd want to steer clear of that zone. That radiation will give you cancer. Well, actually, you get such a massive dose that you'd probably just die instantly. Besides this, the only problem? Well, we don't actually have a white hole, and we don't know how to make one either.